There is a number the United States Navy never officially calculated. It is the number of Japanese ships that reached port between December 1941 and September 1943, because the weapon American submarines were firing did not work. The Navy did not calculate it because calculating it would have required acknowledging, in a formal and permanent document, how many opportunities were lost, how much Japanese logistics capacity survived, and how much longer the Pacific War ran because a bureau in Washington decided that protecting its reputation was more important than fixing its torpedo. That calculation was never made. The Bureau of Ordnance preferred the version of history where the Mark 14 torpedo's defects were identified and corrected through diligent peacetime engineering review and wartime operational refinement. The submariners who spent 21 months firing a broken weapon at targets they could not sink preferred a different version. The two versions have never been fully reconciled, and the popular history of the Pacific War has generally adopted the one that is more comfortable for the institution. Let's do the uncomfortable version. The American submarine campaign against Japanese merchant shipping was, by the end of the war, one of the most strategically decisive operations in the history of naval warfare. By 1945, American submarines had sunk over 5 million tons of Japanese merchant shipping, effectively severing the supply lines that connected Japan's industrial base to the raw materials it needed to sustain the war. Oil from the Dutch East Indies, bauxite from the Philippines, rubber and rice from Southeast Asia, the entire material foundation of the Japanese war machine moved by sea, and American submarines systematically destroyed the ships carrying it. The Japanese Empire was an island nation that had conquered a resource empire and then discovered it could not defend the shipping lanes connecting them. The submarine campaign is the operational story of that discovery. It is a story of genuine strategic brilliance and genuine operational courage. It is also a story that begins 21 months late, because the weapon those submarines went to war with was broken in 3 separate and independently catastrophic ways, and the institution responsible for it knew, or had every reason to know, long before the first torpedo was fired in anger. The Mark 14 torpedo was the product of 15 years of development by the Bureau of Ordnance, the Navy department responsible for weapons procurement and testing. By 1941, it was sophisticated, expensive, and classified at the highest security level. It carried a 668-pound warhead. It ran at 46 knots. It had a magnetic exploder, the Mark 6, designed to detonate beneath a ship's keel for maximum structural damage. It was, according to every Bureau of Ordnance assessment, ready for war. The assessment was produced without a single live warhead test against an actual target. The decision not to test live warheads was not an oversight. It was a budget decision. Live warheads cost money. Exercise warheads, inert, water-filled substitutes used for training and performance measurement, were reusable. The Bureau of Ordnance calculated that the performance difference between an exercise warhead and a live warhead could be addressed through theoretical correction factors, applied mathematically to the depth-keeping data collected from exercise firings. The calculation was wrong. An exercise warhead is significantly lighter than a live warhead. A lighter nose changes the torpedo's hydrodynamic trim. The Mark 14 with a live warhead ran an average of 11 feet deeper than the same torpedo with an exercise warhead. The theoretical correction factors the Bureau had applied did not account for this accurately. The result was a weapon that, when a submarine commander set the depth to run shallow and pass under a target's keel, would instead pass well beneath the keel entirely and exit the other side without detonating. The depth defect was not subtle. It was not a marginal error requiring careful statistical analysis to detect. It was 11 feet of systematic, consistent, reproducible error that sent torpedo after torpedo harmlessly through the water beneath ships that should have been sinking. When the failure reports began arriving in Washington in December 1941, the Bureau of Ordnance's institutional response followed a pattern that will be recognizable to anyone who has studied how large organizations respond to evidence that their core product is failing. The failures were attributed to crew error. Submarine commanders were told their approach procedures were faulty. Their tracking solutions were questioned. The implicit accusation was that men who had spent years training for submarine attack operations had suddenly and collectively forgotten how to do their jobs at the exact moment the war started. The Bureau did not ask whether the Torpedo was running deep. It did not order tests. It did not send engineers to the Pacific to examine unexploded torpedoes recovered from beaches and shallow water. It produced memoranda defending the Mark 14's certified performance specifications and questioning the operational judgment of the men in the field. This response required a specific kind of institutional psychology. The people writing those memoranda were not stupid. They were engineers and administrators who understood torpedo mechanics. They were receiving reports from experienced submarine commanders describing failure modes that were consistent, systematic, and difficult to attribute to random human error. To maintain the position that the torpedo was sound, they had to adopt an alternative theory of the failures that was less mechanically plausible than the one the operational data was pointing toward. They chose the alternative theory because the alternative theory protected the program, the careers built around the program, and the institutional reputation of the Bureau of Ordnance. In the hierarchy of incentives operating on the Bureau's leadership in 1941 and 1942, being wrong about the torpedo was more dangerous to the people involved than being wrong about the submarine force. So they were wrong about the submarine force. The first formal challenge to the Bureau's position came from Admiral Charles Lockwood in mid-1942. Lockwood commanded the submarines operating from Australia, and his operational reports were painting a picture of systematic failure that he refused to accept as a crew competence problem. In July 1942, 7 months into the war, he ordered his staff to conduct a systematic depth test using nets suspended in a controlled bay environment. The results were unambiguous. The Mark 14 was running 11 feet deep on average. Lockwood sent the test data to Washington with a formal request for correction. The Bureau of Ordnance accepted the findings slowly and with institutional reluctance. The depth correction was implemented across the fleet over the following months, a process that itself consumed time and resources that should not have been necessary. The depth correction did not end the failures. By the time it was implemented, operational experience had accumulated enough data to suggest that the magnetic exploder, the Mark 6, was generating its own independent pattern of failures. Submarine commanders were reporting random detonations in empty water, detonations that occurred hundreds of yards from any target, and consistent failure to detonate on genuine attacks where tracking solutions were confirmed accurate. The Mark 6 was designed to detect the magnetic anomaly of a steel ship's hull passing overhead and trigger the detonation at the optimal point for maximum keel damage. In the variable magnetic environment of the actual Pacific Ocean, at the latitudes and water temperatures and sea states where the submarine war was being fought, the Mark 6 was behaving erratically in ways its controlled environment testing had not predicted. The institutional battle over the magnetic exploder was the most damaging phase of the Mark 14 scandal, because it persisted the longest and because its primary defender had command authority over submarines whose commanders were experiencing the failures directly. Admiral Ralph Christie, who commanded submarines in the Southwest Pacific, had been personally involved in the Mark 6's development and was its consistent defender throughout the period when operational data was systematically undermining the case for its use. Christie required submarines operating under his command to use the magnetic exploder, even after Lockwood, operating in the Central Pacific, had authorized his commanders to deactivate it. Christie was not receiving different data from Lockwood. He was receiving the same failure reports. His decision to continue requiring the magnetic exploder's use was a decision to prioritize his professional investment in the system over the operational reality his own submarine commanders were reporting. The men on those submarines did not have the option of disagreeing with the Admiral's assessment and surviving a depth charge attack. They fired the torpedoes they were ordered to fire and watched the results they were ordered not to report as defects. The contact exploder's failure mode was the last to be identified and the most damaging in a specific operational sense, because it was most likely to occur on the shots that should have been kills. Commander Daspit of the USS Tenosa discovered this in July 1943, when he fired 15 torpedoes at a stationary whale factory ship and achieved 0 detonations despite confirmed hits. He brought an unexploded torpedo back to Pearl Harbor as physical evidence. The disassembly revealed that the contact exploder's firing pins were too fragile to survive the deceleration of a direct perpendicular hit. On an angled strike, the pins bent slightly and traveled far enough to trigger the warhead. On a perfect direct hit, the optimal shot geometry, the deceleration was so abrupt that the pins crumpled and failed. 2 years of approach and attack training, 2 years of procedures optimized to produce the perpendicular hit that maximized kill probability, had been producing the exact shot geometry in which the exploder was most likely to fail. The fix, once the mechanism was identified, was implemented in weeks. It had not been identified earlier because identifying it required someone to bring back an unexploded torpedo and demand that it be disassembled. And doing that required the kind of institutional confrontation that most officers in a chain of command were not positioned to force. The strategic cost of the Mark 14's 21 months of defects is assessed through the lens of what the submarine campaign achieved after September 1943 compared to what it achieved before. The contrast is not subtle. American submarines sank more Japanese shipping in the last 18 months of the war than in the first 30 months combined. Some of that increase reflects growing numbers of submarines and improving tactics. But a significant portion of it reflects the difference between attacking with a weapon that worked and attacking with a weapon that didn't. The Japanese ships that reached port in 1942 and 1943 delivered fuel, ammunition, aircraft, and troops that extended the war's duration at every point where supply was a constraint on Japanese defensive capability. Guadalcanal, New Guinea, the Central Pacific island chains. The submarine force that should have been severing those supply lines was running attack after attack with weapons that were producing hit sounds and no damage, and filing reports that Washington was classifying as crew error. The men who ran those attacks knew what they were experiencing. The Submarine Forces Officer Corps was not confused about the pattern of failures. They were watching the same target evade an attack that should have sunk it again and again, across enough commanders and enough patrol areas and enough different operational conditions to make any explanation based on crew error statistically impossible. What they lacked was the institutional standing to force the Bureau of Ordnance to accept a conclusion that the Bureau had every incentive to reject. Lockwood eventually provided that standing, but it took 7 months and a formal test to move the Bureau on the depth issue, and the magnetic exploder controversy persisted for over a year after that. The contact exploder was fixed only when Daspit literally drove a defective torpedo back to port and refused to fire the rest of his load until someone looked at it. The Pacific War's popular history frames the submarine campaign as a success story, which it ultimately was. The raw numbers support that framing. But the operational reality of the campaign's first 2 years is a story about what happens when institutional accountability fails at the point where it connects to combat outcomes. The Bureau of Ordnance's engineers did not intend for submariners to go to war with defective weapons. But when the evidence that the weapons were defective began accumulating, the Bureau's leadership made a sequence of decisions that prioritized institutional protection over operational correction. Those decisions had a body count. It was not the body count of a battle or a campaign. It was the diffuse, unattributable body count of a war that ran longer than it should have, of Japanese supply lines that remained open when they should have been cut, of American servicemen killed in operations that Japanese logistics sustained beyond the point where they should have been sustainable. That body count was never calculated. The Bureau of Ordnance made sure of that. But the absence of the calculation does not make it zero. It makes it invisible. And invisible costs are the most dangerous kind, because the institution that generated them never has to answer for them.